Okay, so put in your date and your title for this evening. Remember, we need graphing calculators for the rest of this week and pretty much for the rest of the year, so make sure that you're getting yours. And we're going to continue with functions. Yesterday we talked about how you would say this was f of x, or the function of x, and you might have something, oops, well, that's not writing very well, plus 2x plus 5. We don't have to use f though. We can have a function of g, so we could say that would be called g of x. A lot of times you'll see h of x. Okay, and the reason for these different letters is they might want you to look at different equations for different inputs. So I might say like this: I want to find what the function is for g of -1. So because this g is here, that tells you you're going to look at the g function equation. Okay, so we're not going to look at f or h, we're talking about g. So input is -1, so then we would put the output in for, or the input in for x, oops, and then we would just solve. So g of -1, that'd give me -2 plus 5, which is 3. Okay, or we might have something different. We might have something that says find g of, not g, sorry, I meant to do something different. Find h of 2. So that means I have to, you only use this h equation, and that's my input. So I plug it in there. So when h of 2 is my input, 9 is my output. So that's sort of the reasoning for these different letter choices here. It all means function, but this is the f function, the g function, the h function. And then if you're given an input, you have to make sure you're putting in which function it's designating, whether it's g, h, or f. Okay, so we're going to do a little bit more with the calculators today. Looking at this, it says graph linear and exponential functions, and hopefully you notice that 1 and 2 are linear, 4 would be your exponential because of the x. So we're going to take our calculator and go to our y equals, and we're just going to basically remember f of x is the same thing as the y, and here's my y, and we're going to put in -2x plus 5. Okay, make sure this is a negative, not a minus. The calculator does not recognize those as the same thing. So if you put a minus in there, it'll look longer, and then you can see that it tells you that's an error. I don't understand what you're talking about. So we go to, and then we should see that that's the negative. Okay, so when we graph this, we get this nice declining function, and I need to graph it here, and I don't want you to eyeball it. I want you to actually put specific points. So on the calculator, above the graph button is the table button in blue. So you're just going to go second table, and what that table does is it gives you all the points on that function. Now this starts when x is -9, y is 23. When x is -8, y is 21. Well, I'd like to kind of find some numbers more in the positive, right? So I can either down arrow, or I can look where it says table set. We're in the table. I want to go to the table set. So if I go to table set, right now my table started at -9. Let's say I wanted to start at 0. So I can just put in 0 here, and then this means it's going by the whole number 1. You can make it go by halves, you can make it go by quarters if you want. You could put in 0.5 for half, 0.25 for quarters, but we'll stick with that. So now I'm going to go back to my table, and you can see it started at 0 now. So I know 0, 5, 1, 3, and 2, 1, and all these other ones are points on there. So we're going to plot that exactly. So I have 0, 1, 2, 3, 4, 5. So we'll put a point here. And then we said we had, oops. Yeah. Then it said we had 1, 3. I can put that in. Over 1 and up 3. And you only need 2 points to make a line, but I might get one lower so I can get the angle right. Maybe 4, -3 would be a good one to put in. So we'll go over 4, down 3, and then we can draw our line, right? Let's draw a pretty blue line. Okay, and so we have our line. Might need to straighten that out just a tad, and then make sure we put our arrows on the end here. Okay, so specific points. Okay, so we can do the same thing for my function g. So we'll bring this over, go back to my y equals. I can clear that out, and I can put 4, make sure we get the minus 3x. Always start at zoom standard, so zoom 6. And then we see, again, it's a decreasing. It's got the negative 3 there. And so we can go to our table and get in some points again. And I can go above that or below it. So we have 0, 4, 1, 1. Got all sorts of choices here. 0, 4, 1, 1, right there. I might pick one more. 3, negative 5, that looks good. So over 3, 1, 2, 3, 4, 5. So that gives me a good idea of how to draw that. So go to my line here and just draw it like so. And we got a nice, very specific, very accurate line. Okay. So the next one, hopefully, you recognize over here is that as an exponential equation. I'm trying to move this up so my head's not in the way. So again, we'll go to our y equals. We'll clear this out. We have 5. Here's my parentheses. We raise it to the x power and my parentheses, and then I can hit graph. Okay, and we can see it's an increasing exponential function. I can go to my table and I can pick out some points. My points are really big. It goes 5, 15, 45. So in this case, I might want to make my x-axis go by 5s, like that 5, 15, or 10, excuse me, 15, and 20. And then you can still keep these as 1, negative 2, negative 3, and so on. So I think we said 0, 15, right? Or 0, 5 is there. What was the other one? 1, 15, right? So over 1 up 15. And I don't think we'll fit the rest on there, right? The next one's 45. And then you can see if you go up, our negative exponents, see the negative 1 is about 1.5. So here we have negative 1, and we say it's about 1.5. So maybe right about there. Oh, here's 1. 1's way down here, right? I made that 5. So 1 would be right about there. So we're going to say maybe about there. And then remember, this exponential functions, terrible line, sorry, is that asymptote. So remember, I told you, if we go up, look at, if we keep going forever and never reaches that x-axis, it just gets closer. You may want to know what these e's are. These e's mean scientific notation, okay? So if I have 2.8 e to the negative 5, so let's just say I had 2.8 e to the negative 5. What that means is it rounded 2.8 times 10 to the negative 5. Hopefully remember some scientific notation there, right? So my video stopped on accident. I'm not quite sure where it stopped, but we went and grabbed this. Then we went to this one and put in the 5 times 3 to the x. And we went to our table, second table, and we looked at how our numbers are kind of going by, up by 5, 15, 45. So what we did was we went ahead and numbered this by 5s. We went 5, 10, 15, and so on. And then we put our 0, 5 in, which was right here. And then we had 1, 15, which is right here. And then we had our negatives, which made that asymptote. If you remember, this is exponential, and it gets closer and closer to this x. Never quite touches that. So remember, that's your asymptote. Okay, I see the problem. Okay, so if we look at all our x and y's on the exponential function, you can see as the negative goes, these numbers just getting lower and lower and lower as they get closer to the x-axis but never touch. And so I was looking at this particular problem right here, 2.8 e to the 5. So that's what that is. And that is sorry, scientific equations, right? Scientific, I'm trying to say, scientific formula. So remember the -5 means this goes over 5 places. So 4 zeros and then the 2 and 8. So this is scientific, and hopefully you remember that from last year. So as these numbers are getting bigger, that E means times 10 to that number of places. And you see, we could go on forever. I won't ever reach it. Okay, that's asymptote. So that's going to be it for tonight. So you're just going to make sure you understand those calculator functions. No questions, just notes. Make sure you get the right keys for the calculator to get that table and to, you know what that E means. Good night.